Hello, welcome. We have some implicit differentiation here. We have this parametric here on theta. If this x is a cosine theta to the power of 4, and y is a sine theta to the power of 4, and at the point theta is pi over 4, we want to find the equation of the tangent and the normal. So for a small refresh here, let's say that to find the equation of a line, we can say that y minus y0 is equal to m factoring x minus x0, where y0 and x0 is the point at pi over 4. So we are going to use that one. First we need to find m. M is the slope. This is what we need here. The slope for both tangent and normal. We know that they are perpendicular. So what we are going to do is take x first. So for x we have dx over theta is equal to, the derivative of this one is 4a cosine cubed theta times cosine theta. When you take the derivative is find minus sine theta. Now to make it better, we put the negative sign here. So this is what we have here, and we could have put d theta, but that's fine. And for the y, dy over theta is equal to the same thing here, 4a sine theta cubed times sine theta, taking the derivative of sine theta, we find just cosine theta. So we have the two. Now if we put dy over dx, what we find here is so dy over x is equal to 4a sine cube of theta times cosine theta over negative 4a cosine cube sine theta. So we can simplify. For a sine theta and cosine theta, drop these to 2, so this equal to negative tangent square theta is the answer here. So this is what we have here now. We have taken the dy over dx. This is just the slope, and dy over dx at that point is equal negative tangent squared of pi 4, but we know tangent pi 4 is equal to 1, so that is just negative 1. So that is the tangent m. So we have for the tangent we have m is equal to negative 1. That makes it for the normal. m1 is equal to 1. So we have the two. We just have to plug them in here, and after plugging in, we get for the tangent, we can find the equation of the tangent quickly by replacing what we are doing. We are just putting y0. Look at let's calculate y0 and x0 here. So at theta is equal to pi over 4. What we have for y, we know that y is equal to, let's see the original equation here, y is equal to a sine theta to the power of 4, so that is equal to a sine pi over 4 to the power of 4. So that yields, let's You can do it that way, yes, if you want. So that will yield a, we know that sine pi over 4 is square root of 2 over 2. That makes it a times square root of 2 to the power of 4. That is just a over 4, because this is a times 4 over 16 is a over 4. The same way for x, you will find the same thing. Remember that at this point, cosine and sine of the angle are the same, so that is that makes it also a to the power a over 4. So once we have that, these are the y0 and the x0. So now we know that y minus y0 is equal to m factoring x minus x0, and m is a over 4 is equal to negative 1 times x. Let's plug in x0 here. x0 is a4, meaning that y is equal to negative x plus a4 plus a over 4. Finally, we can get that y plus x is equal to a over 2, meaning that 2x plus 2y minus a is equal to 0 is the tangent. And for the normal, we do the same thing, and we will find that y is equal to x is the normal. So that is about it. We found that, and we found this one. And coming back to our question, we have just answered this one, equation with the tangent of normal of the curve. And that was all for this one, and thank you for watching. Have a wonderful day.